All right. Welcome to our meeting tonight. I realize that our little slideshow needed a little bit of a zhuzh. Space is not black, so I've got a little starry background. I decided to spice up our slideshow, so give it a little bit of flavor here. Next slide. So we got a lot of things going on tonight. It's actually a really big meeting. We got a lot of action going on, a lot of things to talk about. Bob versus the HOA. So I'm doing the meeting tonight. Robert Circus isn't going to be here because he is taking on the fight against his HOA. So good luck, Bob. Books. Ben Hudgens has graciously offered his books. Most of these books are about $5 a piece. You can talk to him during the break. It's an amazing selection of books. I found one that I have never been able to find, so it's a good selection. Rising Star, a lot of cool things happening at Rising Star. They just finished a work weekend. The 1687 Foundation, we just got our first gig at 1687. There's not a lot that's going to be said about that. I don't even know the dates. That's a Robert Circus question, and he was not really available to... do you know? Okay, 7th of March? Oh, 7th of March. That would be the night before? Are you sure? 7th of March? Isn't that a Thursday? Or Friday? March 8th. That's a Friday. Okay, March 8th, 1687. We're doing a presentation. We got Chris Ashford doing a presentation on the Greenwich Observatory that he visited when he went home. A little bit about solar eclipse outreach and announcement about the club imaging project that's been going on in the background, and a lot more. So next slide. So do we have any visitors tonight? You want to tell us a little bit about yourself?
Hi, my name is Don Kovach. I live in Arlington. I'm retired. I recently bought a Sea Star and want to learn more.
It's a good entry. Anybody else? Visitor?
I'm a member. I'm new. I've been a member for a little over a year. My name's Will Carlton, but this is my first meeting. So, and I live in Flower Mound, and I've got a 8-inch Dobsonian, and then ED 127 refractor, and been trying to learn astrophotography. Okay. All right.
Anybody else? Oh, you?
I'm new.
Okay, well, hi.
Hi. I'm Kiana. Let's see, I am 21. I go to Tarrant County College, and I'd say recently I took up an astronomy interest, so I'm here now. That's what we're here to learn.
Deep dark hole. Welcome. All right.
Hello everyone, something similar. My name's Jacob. Always been into space, but trying to learn to itch the hobby a little bit. So I found y'all's website and figured I'd come out for a meeting.
That's how I got started. Anybody else? I'm kind of worn out. That's where I get my exercise in. Hey, here you go.
My name is Paul Kahn. One of the members here. I signed up for that Eclipse movie because I got a camera a couple years ago and take pictures of my kids, and I've been fascinated by that, and of course the whole space thing. But I can't remember the name of the gentleman that I spoke to, but he told me about y'all's group, and so here I am.
Very cool. Welcome. All right, next slide. Or are there other visitors? Did I miss anybody? I feel like everybody should get the mic that's new so they can tell their story. And it's a funny thing about that. It's like, we're not like, talking about our interests, because it's obviously astronomy, but we introduce ourselves with our name, and then we tell everybody what telescope we got. So, as for the visitors, John Geremini is in the back, the curmudgeon in the plaid shirt back there. So you want to talk to him about membership. So welcome our new members. We've got Daniel Hobson and family. He's here. Welcome. Ken Levin in the house. Dave Titus and family. Welcome back. Vineeth Phillip and family. All right. And AC Jeer and family. All right, well, welcome. Next slide. Okay, so we're founded in 1949. I want you to remember that. We've got presently 198 members. It's all sorts of interest groups, and we're all willing to help each other. It's really a great group. It's why I joined, because I wanted to be surrounded by that sort of thing, and it really has proven to be correct. We're a nonprofit organization, and there's more to learn. Next slide. If you go to our website, it tells you all about it, tells you the story. Other online presence that we've got is Facebook, Fort Worth Astro. We've got a YouTube channel, and then we've got a message board on Groups IO, and is it IO or EO? I don't know. Groups IO. Just read what it says. And then there's astrophotography special interest group. So that's all the camera jockeys in here on the Groups IO site. So next slide. Okay, the executive board, Robert Circus, who isn't here. I'm Bill Hall, John Geremini, you've seen, Monica, Jim Potts, Ted Smith. If you guys want to stand up and identify yourselves to the, that's Ted, there's Cy, Bruce Campbell, and Jim Potts, is he here? Jim Potts is online, I guess. And then Cy again. Okay, next slide. Key contacts. I take these things and I print them to PDF and I post them on the Groups IO site, so you can get all your information by looking at this or take a picture of the slide. Okay, next slide. Okay, so founded in 1949. If anybody's doing their math, that means that Fort Worth Astronomical Society is this year 75 years old. And so we got this letter from the Astronomical Society that just gives us the recognition. Congratulations for being 75 years old. So very cool. 75 more, right? Yes, sir. Very cool, very cool. Next slide. Okay, so I'm going to introduce our presenter. He's Brit. He's our token Brit in the club. And he went back home for, I'm not sure what the occasion was, but he visited the Royal Observatory in Greenwich, England, which is, of course, the Mecca of timekeeping. So, our very own Christopher Ashford.
Can you hear me? Bill?
Yes, sir?
You can hear me?
Yes, we can.
And you can see me. I mean, not me, but the slide.
I can see your slide.
All right, very good. Well, I always try to go home, which home's really here now, but I go back to the UK to visit my mother, whose birthday is in November, so I'm always there in November. Anyway, good evening, everyone. My name is Chris Ashford, for those that don't know me, and my presentation today is about the Royal Observatory in Greenwich, London, and how it became the prime meridian for the world, where east meets west. And I grew up locally in southeast London, and the observatory is about 10 miles from our family home. And I visited it many times. Every time I had a new girlfriend, I'd take her to see timepieces and telescopes. Anyway, it's always fascinated me in my younger days, and today even more fascinating now that I know so much more about astronomy. And as I said earlier, I was in London last November, and I had time to visit the Royal Observatory again. It really struck me how so many things that we all take for granted today were either not known or not well understood, and how challenging it was for the scientists of the day to make sense of it all. So I returned the following day for another visit, took a bunch of photos so that I can share with you today the story of celestial navigation, time, longitude, and how Greenwich ended up being the prime meridian of the world. So the Royal Observatory is one of 4 museums in Greenwich. They're collectively known as the Royal Museums Greenwich, and are certainly my personal favorite go-to museums in London. Apart from the Royal Observatory, the others are the National Maritime Museum, with centuries of naval history. The Cutty Sark is a restored clipper that sailed the tea routes to and from China in the 1870s. And the Queen's House, one of the finest classical buildings in the UK. Now, all 4 of them are worth seeing, but the Royal Observatory is, in my opinion, the best of the 4 museums, and it contains a wonderful record of the beginnings of astronomy that we enjoy today. So I thought I'd just for, if people are new and don't know what a meridian is, I've extracted this slide from the internet. A meridian, or meridians, are imaginary north-south lines on the Earth's surface that connect both geographic poles. So they're used to indicate longitude, and the prime meridian is 0 degrees longitude and divides the Earth into the western and eastern hemispheres. And the graphic here is showing lines of longitude and latitude, with the prime meridian passes through Greenwich. If you look really close, you can see a tiny bit of Britain, Great Britain there. And then it gives us an example of New Orleans, which is 90 degrees west and 30 degrees north. So now, before talking about the Royal Observatory in detail, I would like to set the scene, take you back a few hundred years to a period of European cultural development known as the Scientific Revolution in the 17th and 18th centuries. So, to understand the reasons behind the establishment of the Royal Observatory, we have to imagine what life was like back in the 1600s. This was a time of great social and economic change, and there was a revolution in the development of science and mathematics, all made possible by the ability to print scientific papers and share knowledge all over Europe. And the printing press was developed in the mid-1400s. And before that, scientists had no way to share their discoveries, theories, no way to easily start education programs. So yeah, the printing press was really fueled science development in Europe. And I just selected a few names which some of you may have heard of before or even read about. And so the names I chose, Galileo is an Italian. He developed the refractor telescope and observed the phases of Venus. He identified the 4 major moons of Jupiter and Saturn's rings. Kepler, he was German. He developed the laws of planetary motion. He witnessed the Great Comet of 1577 and the new evening star that appeared in 1604. That, of course, was a supernova, very bright, with a magnitude of -2.5. that could be seen for about 3 weeks. Kepler also improved Galileo's refracting telescope design using a convex eyepiece instead of a concave eyepiece in Galileo's design. Then there was Cassini. Now he was another Italian, but he moved to France, and the Cassini family ran the French equivalent to the Royal Observatory, which is the big observatory in Paris, and they were renowned for producing accurate maps. And then, of course, Isaac Newton wrote over 400 books in his lifetime. He was English and considered himself to be rediscovering ancient knowledge that had been lost during the Middle Ages. So his most well-known publication in 1687 was the Natural Philosophy of the Principles of Mathematics. It explains gravity and the fundamental laws of motion. And then again in 1704, he published a book called Optics, where he's the first person to explain the colors of the light spectrum. And of course, we all have them today. He developed the first reflecting telescope in 1668. And then finally, my final one in the list here, and there are many others, but Edmund Halley. So he funded some of Isaac Newton's publications, because Newton, he didn't want to publish, and Halley persuaded him to do it, and he funded it. And Halley was the first person to correctly predict that a comet seen in 1531, 1607, and 1682 would return in 1758. He also spent a year in St. Helena, which is an island in the South Atlantic Ocean, to map out the stars in the Southern Hemisphere. So now, in addition to the scientific revolution that was going on, it was also a time when all the European powers were jockeying for position, exploring new territory, and being constantly at war with each other. So here, apart from the global expansion of trade, where India, North and South America, Africa, and the Caribbean islands, explorers arrived somewhere, they had no idea where they were. And then on top of that, you had the naval powers of Europe competing. And just in the same period where science is really taking off, there were these wars, I mean, constantly at war. And I won't read them all out to you, but you get the idea. And so this brings us to the theme that was really responsible for the development of the establishment of the Royal Observatory, which is how to navigate the seas of the world. This was the key. All right, so let's talk about navigation at sea. It was an unsolved problem, and it was generally regarded as unsolvable. All the European seafaring nations had put significant effort into finding a solution. But for 150 years, maybe 200 years, they tried, couldn't find it. So we all know latitude, fairly easy to measure. During the day, you'd measure the height of the sun and use charts for that time of year. You would be able to calculate latitude. Or if you're in the northern hemisphere at night, all you've got to do is measure the altitude of Polaris on a clear night. Longitude, however, was a much more difficult problem. So captains would find themselves hundreds of miles off course. Many ships got into trouble, too close to shore, and sank due to poor navigation. And here are a couple of illustrative paintings, pictures I took from the Royal Observatory. So let's have a quick discussion about longitude and understand why it's so difficult to measure. So back to Newton discovering what the ancient Greeks already knew. They knew that longitude is equivalent to difference in time between two locations on the Earth, as measured by the position of the sun. And so a couple of ancient Greek astronomers, 3rd century BC, Eratosthenes proposed a system of latitude and longitude based on meridians and parallels through known locations, with the prime meridian passing through Alexandria in Egypt. But his problem was his meridians weren't exactly straight because they all had to pass through known locations, and those locations didn't necessarily line up on a meridian. It was Hipparchus in the 2nd century BC who proposed a more systematic approach. He's the guy that divided a circle into 360 degrees and then expressed longitude as degrees east or west of the prime meridian. We have a lot to thank Hipparchus for today. For instance, he came up with the star brightness scale that we still use today, the magnitude scale. And then in the 2nd century AD, or CE, Ptolemy, he developed a mapping system that used projections with curved parallels to reduce map distortion. His maps were still quite inaccurate because of a miscalculation of the size of the Earth. And what's amazing about this story is we knew, or the Homo sapiens knew this all over 2,000 years ago. And then that was lost to the Western world during medieval times. However, it did continue in the Greek and Muslim cultures with development of astronomy instruments such as the astrolabe. And here is an example of an astrolabe. It works very much like the planispheres you can buy on Amazon today. It has a fixed scale around the circumference, moving parts which correspond to movements of celestial bodies such as the planets and the sun. Sorry, I didn't get a better photograph of this so you can see the markings in detail, but you'll just have to go to the Royal Observatory to see it for yourself. So, so back to Europe. In the European world, the interest in navigation using astronomy picked up in the West during the 12th and 13th centuries. And it was mainly the Spanish and Portuguese sailors who learned from their Arab neighbors in North Africa. So, all right, to sum up, this knowledge of astronomy led to 2 proposed methods for calculating longitude. So in the early 1500s, the lunar distance method was proposed. And then in the early 1600s, another method was proposed by Galileo after he discovered the moons of Jupiter. So the next 2 slides, I'm going to describe these 2 methods, and then we'll get into the Royal Observatory itself. So first of all, the Jupiter moons method. I'm going to describe this one first because ultimately it was unsuccessful. But it was originally proposed by Galileo. He realized that the rotation of the moons of Jupiter is effectively a clock in the sky. It doesn't matter where you are on the Earth's surface. If you can see Jupiter, then every observer will see the transits and occultations of Jupiter's moons simultaneously. So if you can measure moon transits accurately and have ephemeris data for Jupiter's moons, plus star transit charts as a reference for local time, then you can use the time difference to calculate longitude. So, well, let me explain that another way. Let's say you observe Ganymede starting an occultation behind Jupiter. And at the same time, you're looking at, let's say, Pollux nearing the meridian. 1 minute later, Pollux reaches the meridian. And then you look at your ephemeris data from the Royal Observatory and note that after Ganymede's occultation starts, from the Royal Observatory's point of view, Pollux transited the meridian 3 hours beforehand. So the difference in time between your location and the Royal Observatory is plus 2 hours, 59 minutes, i.e. you are behind, i.e. to the west of the Royal Observatory by almost 75 degrees of longitude. That's, you know, you're almost 3 hours times 15 degrees, and you'd be able to calculate it. So that sounds pretty straightforward, right? However, yeah, easy on land, maybe. Maybe we should have a little competition next time we go to Rising Star for who can calculate longitude first. And I believe Jet Propulsion Labs provides ephemeris data for Jupiter's moons, and you can get star transit times from most planetarium software. Anyway, it was used by James Cook to map out locations in his famous 1768 to 1771 circumnavigation of the world. And it was successfully used on land by the Cassini family to map the coastline of France. And the King of France at the time complained that he had lost more land to his astronomers than all his enemies. So I took this photo I flattened it out for everybody. You can see how much of the coastline of France receded due to accurate measurement of longitude using Jupiter's moons. So now attempts were made in the late 1700s to make this method work. While at sea, people came up with numerous ideas, such as a sea chair mounted on a gimbal, times 80 magnification binoculars. But none of these worked, and ultimately this method was unsuccessful and abandoned. So imagine trying to see the moons of Jupiter from the deck of a moving ship with a 3-foot telescope. That's going to be a challenge, and they tried and gave up. So let's talk about the other method, the lunar distance method. So the moon moves the distance of its own diameter in about an hour, and that's a distance called a lunar. So this steady motion can be used to measure time. In 1752, German astronomer Tobias Meyer produced accurate tables of lunar motion based on observational data provided by the Royal Observatory. The sextant was developed in 1731, and this enabled accurate measurement of star positions at sea. So using a sextant, a navigator measured the separation between the moon and a particular star. And then you'd look up in the almanac, in the first edition of the annual Nautical Almanac and Astronomical Ephemeris, was published using Royal Observatory data in 1767. The tables were accurate enough to determine the moon's position to within 75 seconds, and subsequently longitude at sea to about ½ a degree, which is about 30 miles at the equator. So a mile is defined, the definition of a mile is 1 arcsecond of longitude at the equator. So that finishes setting the scene, and now let's get into talking about the Royal Observatory. So in 1675, King Charles II issued a royal warrant appointing John Flamsteed as the first astronomer royal, charging him with rectifying the tables of the motions of the heavens and the places of the fixed stars, so as to find out the so much desired longitude of places for perfecting the art of navigation. So this was the primary goal of the observatory, was to figure out how to navigate and how to calculate longitude. They had a budget of £500. That's really not much. It's around about, I think, £7,000 today. And for those of you who don't know what exchange rate is, well, I don't know what the exchange rate with America was in 1676, but today it's 1.2. So, £70,000 is like $85,000. Really not much. Some of you may have heard of Christopher Wren. He designed St. Paul's Cathedral, which is one of the major tourist attractions there in London today. And money was a little tight in those days because of the Great Fire of London. The observatory is about 6 miles from central London, which in 1676 was enough to avoid the smoke rising from the city. London had been an urban sprawl with about 350,000 inhabitants. They had open fires, candles, ovens, stores of combustible material, and the Great Fire of London had destroyed much of the city in 1666. And in those days, buildings were mainly wood and thatch, so their construction. The fire is estimated to have caused £9 to £10 million worth of damage, and even a decade later, rebuilding was still ongoing, especially for larger projects like St. Paul's Cathedral, which was finally completed in 1708. So Greenwich was chosen because there was already a foundation there from a derelict castle, and it was in a royal park, so the king already owned the land. And it was on top of a hill which gave unobstructed views to the horizon. So in 1676, the Royal Observatory was completed, and what was built on my photo there is just the right-hand side. The left-hand side building was an extension at a later time. So let's talk a bit more about that. John Flamsteed the observatory was named Flamsteed House after the first Astronomer Royal, John Flamsteed. So it comprised of just 4 dwelling rooms where the royal astronomer and his family lived, and the great star chamber, which is known now as the Octagon Room, and you can see the little photo there. It had a high ceiling to accommodate the very long telescopes of the day. These telescopes were refractors, but they suffered from really bad chromatic aberration. And they didn't have the lens manufacturing methods that we have today. Anyway, the solution to chromatic aberration, which made the image completely blurred, was to increase the separation between lenses to create a sharper image. This, however, created longer and longer telescopes that were awkward to mount and use. And you see an example of one. That's a short one. Some of them were much longer than that. The room also had 2 very accurate pendulum clocks. They had very large weights and 13-foot pendulums, which were hidden in the paneling. So you see them in my photo. It's just the clock faces and the weights, but those go right up to the ceiling. They only needed to be wound once a year and kept such good time that Flamsteed was able to prove that the Earth rotates at a constant rate. This observing room had limited use for serious astronomy, because what Flamsteed really needed was a mural telescope fixed on a meridian. So the Octagon Room it was mainly used for entertaining guests, casual observing of the moon, planets, stars, and much of Flamsteed's work was done in another building that he constructed in the garden. So the Meridian Observatory. So this is the left-hand part of the facility, and you can see this aerial view. I took this. Actually, this shot is from a little brochure from the museum. So Flamsteed House is the bottom part. That was what was built in 1676. So the Meridian Observatory, that was an add-on by various astronomer royals, which I'm going to take you through now. So the Meridian Observatory, personally for me anyway, this is the most important room in the whole museum. And it's really amazing to see how different the telescopes of the 1700s were from what we use today. Edmund Halley succeeded John Flamsteed as the Royal Astronomer in 1720, and he added his quadrant room. I'm going to show you pictures of this in a minute, in 1725. But that was demolished by James Bradley in 1749 to make room for a new observatory. And then it was further extended 1809, 1813, 1855. And we have what we see today called the Meridian Observatory. So here you can see me standing on the Greenwich Mean Time Meridian, 1 foot in the east, 1 in the west. And behind me, you can see the Meridian Observatory, which has 3 meridians in it. So there's Aries Meridian. This is what became Greenwich Meridian. Bradley's Meridian was defined in 1750 and still used today as the reference point for British Ordnance Survey maps. And then Halley's Meridian, created in 1725. That was the first meridian to be used to measure transit times of stars that was so important for navigation at sea. All right, so let's take a look inside. So these are just some of the instruments in the Meridian Observatory. There are many others. Plus, when there, you can expect these closely to see how they're adjusted and imagine what it must have been like to actually work on cataloging the stars. The early instruments, telescopes, had a focal ratio in the range f30 to f40. In other words, they had a focal length of about 8 feet and an objective lens of only 2.5 or 3 inches.
Like something that
So-
part of the meeting,
Oh,
probably.
there he is.
So as you can see, they started out with a
I
telescope.
thought the guy is from that
Why can't I hear him?
observatory over there. He may be showing pictures.
Hey, Laverne, your
What did it say?
microphone's on.
A.
Can you hear us?
Looks like what he be.
Thank
Oh,
you.
thank you.
Okay, so as you can see, they started out with a telescope that's attached to a quadrant, which is then attached to a stone wall and aligned to a meridian. So no movement in azimuth at all, only altitude. And you need several people to operate these scopes. You need an accurate recording of time, someone to adjust the scope altitude and record the value, and somebody to observe the stars as they transit the meridian. And you're also sitting precariously on a step ladder for low altitude stars or lying down for high altitude stars. Plus, of course, you need an assistant who's good at mathematics to convert measurements into right ascension and declination. I'm going to talk about that a little bit further. But first of all, let's have a closer look. This is the 8-foot mural quadrant, 1725, made by George Graham. And unfortunately, the heavy brass angle scale caused the iron and mahogany frame to distort, making Halley's work obsolete. And you can see there the adjustment wheel for fine adjustment. Whoever's looking through the scope had his hand on that brass wheel and would rotate it, and there's a thread down here, and that would minutely adjust the scope up and down. The next one is the zenith sector. 1727, again made by George Graham. It was used to view the stars directly overhead at the zenith. So measurements from this instrument proved that nutation was, that Copernicus was correct, that nutation of the planet actually happens. So he's the one, this instrument here is what proved precession, as we call it, or nutation. This instrument, another 8-foot mural quadrant made in 1750. This one had a stronger brass frame to avoid distortion. These early quadrants had a scale of 96 divisions, not 90 as you might expect. Because I was thinking, well, there'd be a 0 to 90 scale on this quadrant because it's a right angle. But no, the scale is 96 divisions. And that was because the manufacturers couldn't divide 90 into smaller, accurate divisions. They had no manufacturing technology that would enable them to do that. So they could do it with 96. And I even had a close look at it. You can see the name Bird London, he's the manufacturer, and he's put on there 48, which is equivalent to 45. So when you're using this telescope, you had to look it up in a table, and they had divisions on the outside, and you had to look up for that division what angle that really meant. This is the mural circle in 1810. This instrument allowed astronomers to measure angular height of the stars over a much larger range. And this was made possible by the invention of the dividing engine, which allowed precision degree scales to be constructed. So they finally overcame that manufacturing limitation of the previous telescope. And then this is the last one. I'm sorry, now I wish I had a better photograph of this. This is so interesting, and I could have done a better job. But George Airy, and of course we see Airy's name. If you read the spec for a scope, you'll see a number for the Airy disk diameter specification for a telescope today. Still exists today, and he was the 6th or 7th, I don't remember, Astronomer Royal. And he designed this instrument in 1850 to define a new meridian with greater accuracy. And it's known as the Airy Transit Circle. It made about 600,000 observations over a century. And this telescope also has a very sophisticated method for recording time and altitude of the star as it started its transit. And I'm sorry, I don't have photographs of that, but it's like you have to stand there for at least half an hour to figure out how on earth they managed to do it, how they made this system work. So anyway, all right, let's continue on. Here's a timeline. So the first 5 Astronomer Royals, John Flamsteed, he established the Royal Observatory. He authored the first accurate star charts using right ascension declination coordinates. And, excuse me, his name, his legacy continues today in the form of the Flamsteed Astronomical Society, and they hold star parties on Blackheath Common, which is nearby. And they have observing evenings through the great equatorial telescope, which I'm going to come to later. Just I want to say something about right ascension and declination. There was a problem in the early celestial navigation in having a universally accepted reference system for defining where stars were in the sky. So it was Flamsteed that settled on the equatorial system that we use today, i.e. right ascension and declination. And this is the coordinate system that he used in his star catalogue published in 1725, which is 6 years after his death. His wife got it published. He'd finished it, and there was a big argument between him and Newton and Halley. Edmund Halley and Newton went to the Queen and got permission to publish Flamsteed's star catalogue without his knowledge or without his authority. And there was a big, big punch-up, metaphorical punch-up. Anyway, but all the corrections that Flamsteed wanted to make, or the inaccuracies, that things he wasn't happy with, they got made, and it was published in 1725 by his wife. And again, we have to thank Hipparchus for coming up with the equatorial system that we use today. Imagine that, 2,000 years ago, the Greeks, the ancient Greeks, they figured all this out. And at the time, in the early 1700s, well, the 1700s generally, there are other systems in place. There's the as-alt, or as I've written here, alt-as, uses the local horizon as a reference point. So we understand that. But then there's the ecliptic system, uses the plane of the orbit of the Earth around the sun. And then the galactic system, which was used by William Herschel in the late 1700s in his star catalogues. So, and also, look at the timeline here. Consider the timeline to the first nautical almanac. And this nautical almanac basically was the first publication which had the lunar distance method built into it. It took 101 years from the establishment of the Royal Observatory to publishing the first nautical almanac, which enabled you to calculate longitude. And I was wondering what would happen today if you started a research project and told the funding organization you'd have an answer in 100 years. So, these people really, they struggled for so long over so many things. It just boggles my mind when I think about it. So, on to slide 18. The Royal Observatory has artifacts from the 1700s, so we can really get a feel for what it takes to navigate at sea. So here we see a page from the Nautical Almanac showing the distance of bright stars from the moon at 3-hour intervals. And there were telescopes on ships. I've got a picture of a couple of them up there. But telescopes weren't used for stargazing, they were used for looking at the land. I mean, imagine trying to see the moons of Jupiter with one of these from a moving ship. It would be impossible. And the backstaff was used to measure the moon's altitude. You could also use it to measure the sun's altitude. You'd put your back to the moon, and hence its name, backstaff, and you'd observe the shadow cast by the upper vane on the horizon vane. So this part over here on the instrument. Anyway, it was invented by the English navigator John Davis, who described it in his book Seaman's Secrets, 1594. So this was a forerunner of the sextant. And here I've rotated one of the pages. So you can see the star names of the days of the month of January in 1789. And you see the stars Alpha. I had to look this up. Alpha, it's the brightest star in Aries. So Alpha Arietis is what we know as Hamel. And then Aldebaran Pollux Regulus Spica. And you can see it says there, differences of the moon's center, and the rest of it says from these stars. And it's all in the book, and you just calculate the differences and look it up. So I've got another page here, just so, you know, we think of people in this period of time as sort of a little bit backward. Well, they were technologically speaking, but the brains required to calculate longitude at sea, you really get a feel for it when you look at this worksheet. This is a worksheet, a longitude calculation worksheet, September the 5th, 1767. And I just blew up one section on it. And once you've figured out the zenith and the polar distance, done the sine of various angles, added this and doubled that and subtracted something. And then once you've made those calculations, you then had to do corrections for parallax errors and refraction errors, because the Earth's atmosphere refracts the signal. So they knew that. So they provide more math for that. And then they had charts. This amazed me. This one on the right is a longitude chart for calculating parallax corrections. Because you're looking at a star and then you're looking at the moon, and there's a parallax error you're going to get, and this corrects for that. So apart from a good knowledge of star and moon movement through the sky, the mathematics involved, a good understanding of trigonometry and the use of logarithms to do your calculations. So, all right, now, the next slide answers a question I'm sure many of you are asking yourself. If the ancient Greeks knew that the difference in longitude is equivalent to the difference in time, why didn't the sailors of the 16th and 1700s just take a clock with them on their ships? All right, well, here's the answer to that. Oh, coming up, hold on. There wasn't a timepiece in the 18th century, the 1700s, that would keep accurate time on a ship. Accurate clocks of the day, but they were very accurate, but they used pendulums, and that did not work well on a ship. Okay, so what about watches? Pocket watches were available, but only accurate to a few minutes a day. And for navigation, a timepiece needs an accuracy of a few seconds a day. So I calculated it for you. I said earlier that 1 mile is 1 arc second of longitude at the equator, all right? So 1 hour, we know 1 hour is 15 degrees. That's the rotation of the Earth. And that equates to 1 minute is 15 arc minutes, right? So a typical passage to America in the 1700s was 6 weeks. That's 42 days. So a 2-minute daily time error, let's say, equals 42 days times 2 minutes times 15 arc minutes, sorry, gives you 1,260 arc minutes, which is equivalent to 1,260 miles at the equator. And now you see why so many captains, so many ships got into trouble trying to calculate longitude and estimating the time that they left the port. How many, you know, what hour is it now? They didn't know. They really didn't know. And they tried. Here's 1712 pocket watch movement made by Tompion and Graham. And there's a 1660 pendulum clock intended for marine use, but none of these things worked. And here's there's an interesting exhibit they've got. It's got little actuators, and it demonstrates, just in case you weren't convinced, it demonstrates exactly why a pendulum doesn't work on a moving ship. So yeah, you can see it for yourself. All right, so now the Longitude Act of 1714 was an act of parliament. And it was, the precursor to it was the Shovel Disaster of 1707. So this was a huge loss of 4 warships of a Royal Navy fleet off the Isles of Scilly, which is very close to the UK, in severe weather on the 22nd of October, 1707. And over 1,300 sailors lost their lives. And the disaster had been attributed to a combination of factors, including the navigator's inability to accurately calculate their position, errors in available charts and pilot books, inadequate compasses, and Admiral Shovel and his flagship HMS Association sank with all 800 men lost. And this was the driving force for an act of parliament. They offered a reward of £20,000. It's about 2.5 million pounds in today's money for a practical method of determining longitude at sea. And to oversee submissions and awards, there was a longitude board established. Now, the Brits weren't the first to have a go at this. The Spanish and the Dutch had already tried incentive schemes in 1576 and 1600 respectively, but were unsuccessful. And then it was England and France that sponsored observatories in Paris in 1667 and Greenwich in 1675 to provide astronomical data. So anyway, so we've got this this huge amount of money. Lots of people had a go at it. And by the way, Sir Shovel, he was a war hero in his day. People lined the streets at his funeral, and his body is interred at Westminster Abbey in London. So you can go and see it for yourself. He has a monument. It's carved in marble in the South Choir aisle at Westminster Abbey. And I know you're all going to be booking your flights immediately after this presentation. So on to development of the marine chronometer. So 2.5 million pounds is a lot of money, a lot of money. Sorry, 20,000 pounds. And John Harrison, 1693 to 1670, oh my gosh, let me say that again. 1693 to 1776, that's the span of his life. He was a joiner and a self-taught clockmaker. He devoted much of his life to solving the time at sea problem. And by the way, all these are photographs I took from these working timepieces at the Royal Observatory. You can actually see them ticking along. And I do have some video, but I wasn't sure video would go over Zoom very well. Anyway, Harrison's first seafaring timekeeper, instead of a pendulum, it used two connecting bar balances to cancel out the ship's movement. It weighed 74 pounds. It performed pretty well in sea trials, so well that the Board of Longitude gave Harrison £250. That in itself is quite a lot of money, to develop an improved version. However, Harrison discovered a fundamental flaw, so started work immediately on an improved design. So the third design, that was completed in 5 years, but then Harrison spent another 14 years refining it. And he wasn't achieving the accuracy needed and found that the heavy balances were unstable. So he began working on a radical new prototype, which became his fourth and final effort. The fourth design was so much smaller and lighter than previous efforts that the Board of Longitude had serious doubts as to whether it would perform at all. Nevertheless, on a return trip to the West Indies, that's what the British calls the Caribbean, by the way, the West Indies, it performed extraordinarily well. But this timepiece took 6 months and £500 to manufacture, and it didn't satisfy the Board of Longitude's requirement of practicality. Now, one of the criteria of the Board of Longitude, that submissions had to come with what we would call today the intellectual property. In other words, the design and the manufacturing method had to be shared along with the clock. And in 1771, another watchmaker, John Arnold, simplified Harrison's design, and he used new French watchmaking technology to create a new timepiece that could be produced for just £65. And that was in 1771, and the final award of the remainder of the £20,000 to Harrison was made in 1772, 14 years after completing this clock. So it's sort of interesting that he gave up his intellectual property, somebody else developed a cheaper version, but then he still got his reward money. So the marine chronometer development and improvement continued through the 1800s, and the British Royal Navy provided annual trials for the best chronometers, which would then be purchased, and the makers would earn themselves the right to describe themselves as maker to the Admiralty. That was a big deal in those days, lots of money. So, okay, now I'd like to switch a little bit to talk about time and the Greenwich time ball. So you saw in my photograph there, that red ball, which is on a mast. And so now that ships had marine chronometers, keeping them accurate and synchronized was a challenge. And the time ball was installed in 1833 to provide an accurate time signal to ships in dock and on the River Thames. So at 12:55, it's hoisted halfway. At 12:58, it's hoisted to the top, and it was 12:58 when I took this photo. And then at exactly 1 o'clock, the ball is dropped, and it's still operating today. And it was the custom of ships, by the way, in the ocean to share their time if they passed, if they were visible. But time relative to what? And to which meridian? And all British ships were using Greenwich Mean Time. So now we have to talk a little bit more about time. So let's go there. Time in the 1800s. So this is what I meant by things we take for granted. I had no idea that time would be such a fascinating subject until I went to the Royal Observatory. So time was regulated by the sun. Every town in Britain kept local time using a sundial, and time varied from east coast to west coast by 29 minutes. So every town had a different time. And on top of that, astronomers provided mean time equations to smooth out variations in solar time. And that's what the word mean means in Greenwich Mean Time. So each day started at noon because, well, you're looking at the sun. You're looking at the sun at its highest point in the sky. And so each day started at noon, and that caused problems with calendars. Some calendars had the day of the month starting at noon, others had it ending at noon. So, and the different organizations kept different calendars. Here's a point of interest. The Belleville family sold time to subscribers across London from 1830 all the way through to 1940. And John Belleville, he worked as an assistant at the Royal Observatory. And it really blew my mind that that time was something you could sell. But of course, in the absence of, time synchronization, things that we have today, it was important for businesses or for watchmakers, clockmakers. They all wanted accurate time because they want to sell timepiece that's actually got the right time in it. And so the Belleville family, John Belleville, his wife, his children, they carried on that subscription service all the way through to when it finally ran out in 1940. So 110 years he sold time to people across London. And of course, this was happening in every town in the UK. But the advent of the railways in 1830, the 1830s, excuse me, railway timetables, that became a forcing issue for standardization. And there was a proposal to synchronize time across the country electrically via telegraph from Greenwich. And at the same time, in the US, there were 60 time standards. And a traveler from Maine to California, for instance, would have to change their watch 20 times to ensure they made their connections. So there was huge resistance to this idea of standardizing time. There were news articles in the press accusing the railways of aggressively lining their own pockets at other people's expense. And time was being sold in every town, every city in Britain. So standardization would put all these people out of business, But it wasn't really just an issue of passengers making connections. It was, perhaps more importantly, it was for accurate train signaling and safety. So eventually you know, they persevered and they got what they wanted. So the development of the commercial electrical telegraph in Britain in 1837 and in the US in 1844, followed by undersea telegraph cables in the 1850s and 60s, and the growth in international trade drove the world's countries to agree a standard for longitude and therefore a standard for time. So apart from Greenwich, there were other meridians being used in the mid-1800s. For example, Washington, D.C., Rio de Janeiro, Stockholm, Berlin, Paris, and many others. Every country had their own meridian. But Britain led the world in submarine cables and owned 2/3 of them. This was a great time for Britain, the British Empire. Colonialism was going pretty strong. So because Britain was able to synchronize time with so many different countries across the world, Britain really dominated the whole market there. And in 1883, US railroads established 5 time zones. So that's when the time zones that we have today were brought into being. But they used GMT as the reference, Greenwich Mean Time. And then in 1884, US President Chester Arthur, he convened a conference in Washington, D.C. 26 countries sent 41 delegates, and they agreed that Greenwich Mean Time would be the prime meridian for the world, which is, you know, bearing in mind the history there, was pretty much a fait accompli. Now, this brings the main part of my presentation to a close, because that was my goal, is to explain, well, how did Greenwich Mean Time become the prime meridian? But I've only covered a fraction of what is actually available to see at the museum itself. So just to whet your appetite, because I know you're all going to go and buy tickets to London tomorrow. Here are a few photographs, other photographs of interesting things. So here's the Great Equatorial Telescope of 1893. It's a refractive scope with a 28-inch lens, still operating today. And if you want to observe through it, all you've got to do is join the Flamsteed Astronomy Society, and you can have a look through it, no problem. Flamsteed's sidereal clock, this tells the time in degrees instead of hours. I stood there for like 15-20 minutes trying to figure out what the time was. The Shepherd 24-hour gate clock. If you didn't want to buy a time subscription service, you could walk up to this gate clock. It's accurate to half a second. It was installed in 1852. Here, William Herschel's 40-foot reflecting telescope. This was a European, people would travel from all over Europe to see this scope. Herschel, you know, he lived in the same time period, but he was an amateur. He wasn't a professional. And like many other astronomers of the time, they were hunting for comets, but they were discovering nebulae, galaxies, star clusters. And Herschel found himself suddenly famous when he discovered Uranus in 1781. The Dolphin sundial corrects for variations of the sun's apparent daily motion. There's a bunch of, so many interesting things. An armillary sphere planetarium, nocturnals for finding the time at night, to have a little notch on them so that you can feel the time when you can't see it. And if you go in November, when you leave at 5 o'clock, yeah, no kidding, it's going to be dark because of the latitude of London. It gets dark around about 4:30. So when I took this photo, the lights were on. And so this is the end of my presentation. I'm sorry, Bill, I wasn't tracking the time, and I've overshot my allocated time by an enormous amount. But I will take questions if anybody has any.
Oh, man. You got any questions? I do want to apologize. I mispronounced a word when I was introducing you. It's observatory.
Observatory. How did you pronounce it?
Observatory. Yes, we don't say that here. Hey, absolute brilliant, fascinating presentation. Yes, hang on a second.
I have a question about the time ball.
Yes.
Once they drop it, how long does it take to fall?
Oh, it has to fall very quickly. So I've got a video of it. I'll review the video and let you know, but it falls within like half a second. I mean, goes straight down.
Wow, that fast? Okay.
It goes pretty fast, yeah.
Okay,
It
thank you.
has to go, yeah, it has to go fast because it's got to be like an instant in time. But I'll review that and come back to you on it.
Cool. Any other questions? All right. Thank you so much, Chris.
Right. It's a pleasure.
Brilliant.
I'll be back in March for at the meeting.
All right, so we're going to take a break for 10 minutes. I'll bring up the eyeball killers. Watch your eyes. Watch your eyes. And yeah, we'll be back in 10 minutes for a raffle and other things. Okay. Right. All right. First raffle ticket I've got 480-7732. Last four digits 7732. Not me. All right. All right, next ticket. Last four digits 7694. Do we have a winner? We have a winner. Not me again. All right. Next ticket, last four digits 7674. Not it. 7674. Oh, is that you? Oh, look at you. Oh, I like that one. All right. Is that five? Is that four? That's four. Okay. Last ticket. Last four digits 7716. 7716. Not it. Must be present to win. 7716. All right. That's it. Cool, cool. All right. All right, next slide. So before I get into the whole what's in the sky thing, the Solar Eclipse Committee is going to be speaking about giving an update to their the whole outreach effort.
Chris, you don't want to go?
Hey, so my name is Juan Martinez, and then we'll have Chris Mlodnicki, and if we've got time here, if I can purchase some air minutes from Bill. We'll get a Christian Pasensic in here as well. Chris, this is your chart. We need a button pusher, Bill. I don't want to steal your thunder, man. You put a lot of work into this.
Okay, so this is what we're doing. There's lots of stuff that we're doing. First of all, eclipse safety video series. So I already have one for the annular eclipse. Right now I'm working on the one for the total eclipse. There has to be additional information in there. It has to be specifically about totality, let people understand exactly what's going on with totality. So when they can wear their the safety glasses, use the filters, when to take them off, when to put them back on. That is super, super important. People do not know this. We know it from experience. Most of the general public does not. And then we also have to tell them point blank, during totality, take off your glasses, take off the filters, because you won't see anything otherwise. People don't know. You have to tell them everything. Assume people know nothing. And if they say, okay, yeah, I know that, great, fantastic. Until that point, tell them everything. The smallest details matter. Something that to you is, it just assumed, something you think is common sense, it's not common sense. People do not know. Let them know. The Eclipse YouTube live stream. So right now, I have this set for starting at 11 a.m. on the 8th of April. I'm going to change the time depending on lots of factors. We'll see how exactly when it starts and when I need to start it. So the idea right now will be down in Grandview. So for anyone who's new, anyone who doesn't know yet, I have family land down in Grandview, Texas. It's about an hour south of downtown Fort Worth. If the traffic is good, I'll get into that in just a minute. This is important. I was down in Keene on Friday and on Saturday night talking with the Thompson Observatory down there. There was a meeting of the emergency managers and city council and a bunch of other people apparently, and they were talking about how bad the traffic is going to be. They're expecting 250,000 people in Ennis, okay? Not residents of Ennis, people coming to Ennis. Ennis, if you don't know, is not a very large city. Hillsborough, same thing. A lot of people coming into there. Hillsborough is also doing a cowboy music festival, and Letitia Ferrier is going to be down there talking on that day. So expect lots of traffic. They're also expecting 4-hour delays in traffic. So leave early. Leave early.
I'm a ham radio operator from Johnson County, from Cleveland, and we're expecting between 100 and 250,000 people in the county.
Yeah.
And even after I get done with the eclipse, they're asking me to be ready to do traffic control for the rest of the night.
Yes, so for anyone who didn't hear online, there was a comment that we have a ham radio operator from Johnson County. They're expecting 100,000 to how many? 100 to 200,000 people in Johnson County with heavy traffic. So plan accordingly. My plan right now, again, assuming good weather, always assuming good weather, I will be in Grandview probably Friday, Saturday, and Sunday. My intention is set up Saturday, get all my equipment set up, get everything, get all the mounts polar lined at night, and all the cables run. Sunday is a dry run, making sure everything works, and then the actual event on Monday. So what I mean by dry run is everything is connected, all the cameras are connected, we're tracking, doing everything exactly as it was live, go through the motions, blah, 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 trigger the cameras, make sure everything works. Incidentally, camera triggers, if anyone needs information on how to trigger your cannons and do it fast, and I mean really fast, let me know. I brought a couple of samples. There is, if you go on eBay, I put in the link in the Groups IO from a couple days ago. It is Cables Unlimited on eBay, and they have, it's called an optoelectronic trigger for Canon. If you just search optoelectronic Canon trigger, you will find it. There's only one on there. They sell the kit with the little serial to cable connector as well as a USB adapter for it. This, with the right software, will let you trigger your camera as fast as it will take the pictures. If you don't do this, if you try to use a USB, you can only get 1 shot per second, okay? That's it, 1 shot per second. And on top of that, if you have multiple cameras connected to your computer, it will round robin it. So it'll be 1 second, 1 second, 1 second, and then go back to the first one. If you wanted to go fast, you have to use these things, okay? This is for bracketing. So if you don't know what bracketing is, you take images from 1/8,000th of a second all the way to about 5 seconds, and at every graduation in between. And you want to do that because you're trying to get images of the prominences, the flares. You want the chromosphere right next to the sun at the fastest rates. And then you want the inner corona, and then you want the outer corona. And if you're exposing for any one of those, everything else is either going to be overexposed or underexposed. So it's really important. That's on Sunday. So anyone who wants to come, again, pending the weather, anyone wants to come Saturday or Sunday to get set up, absolutely fine. This is family land. This is private. My cousins live there. So no one's going to come mess with it. If they do, the Beagles will let everybody know. So, Robert? Yeah, probably. It's 30 acres. There's 30 acres out there. There's plenty of space to spread out. I may actually spend the night there Sunday as well, depending on traffic. So my plan was actually get there about 5 o'clock in the morning on Monday. But yeah, overnight, sleep in your car, that's fine. I'll talk to my cousins about tents. Again, there's plenty of space. We're trying to figure out how we're going to do parking. In terms of food, barbecue and pizza. We're not charging anything for club members to come. Again, this is a private event for club members, invited guests, astronomers. This is not open to the general public. We're not charging for parking. We're not charging for anyone to be there. It's basically like, hey, can you help us pay for food and bring some food along? This is like a potluck. That's really all that we're expecting. So Monday, the live stream will go. I have a bunch of cameras. I have a bunch of telescopes. I hope everything works. We'll see how it goes. And part of this is also, I've got a couple projects going on. We have the Eclipse Mega Movie, so I'm taking images for it's a project that we did in 2017, and the idea is everyone along the path takes these bracketed images with darks, flats, and biases, and from there, we send the data off, and they'll be able to create a movie out of it, and the intention is we want to be able to see how the chromosphere and the inner corona change during that time, during the 45 minutes or so, however long it is that it crosses the U.S., and then see how those effects close to the sun affect the outer corona later on. So we can see the outer corona really well from satellites like SOHO. We do not have good imagery or a good idea of what happens in the inner corona except during a total eclipse. That's the purpose behind the mega movie. There is also another project I'm doing. Is too many projects, really. There is the Soundscapes project. This is a little wideband microphone that is recording animal sounds. What we do is we take it, we put it out. The thing runs on like 3 AA batteries for 5 days. You put it out 2 days ahead of time, let it run for 2 days, let it run the day of the eclipse, and then 2 days after. What this does is gives us a baseline of animal sounds, insect sounds, just nature sounds, before, during, and after. So it's picking up bird song, it's picking up crickets, because crickets are, well, pretty ubiquitous. They are everywhere. So we can hear that stuff. We heard this in 2017. The eclipse started, the birds quieted down, it got darker, and then the crickets got loud. And then when the sun came out again, the crickets quieted down again. So we want to get that information out there. In terms of also NASA, so some people know, some people don't. Most people don't know yet. NASA is coming to Dallas-Fort Worth. A film crew from NASA is coming to Dallas-Fort Worth the week before the eclipse, and they're going to be visiting a bunch of locations, a bunch of people in the area. They're going to be shooting B-roll. They're going to be talking with people and doing interviews. They're going to be at my house that week. So I have to get all my stuff set up in the backyard. I have to clean the house. I have to clean the pool. I have to clean the backyard. I have to get rid of the kids' toys and make it halfway decent, mow the lawn, everything like that, so everything looks good. That'll be really cool. It'll be a nice plug for the club because it's me doing the club stuff. What else is there? Juan, can you think of anything? That's the big stuff.
There'll be more details next month.
Yeah, more details next month. There's also talk with, I'm still waiting on this information. NASA is doing the live stream from the Indianapolis 500. Apparently the director of the NASA live stream for the eclipse is a big Indy 500 fan, and he talked to the Indy folks, and they're doing the live stream from the Speedway. So on top of that, they're also wanting to pull in live streams, and this is the part I don't have any information on. I'm actually waiting for it. They're pulling in live streams from various people along the path of totality. So I'm going to see if I can have one telescope and one camera dedicated for NASA so that goes out to them. And what they said is they're going to be showing it up on the big screen. They're showing it during the live stream, and it'll have my name on it and the club name underneath it. Again, publicity. Come on, people, we got to do this. We got to get the name out there. So this is one of the ways. The Eclipse Ambassadors Program, this is all part of it. This is also with the Astronomical Society of the Pacific. There's just so much to do. This is the outreach stuff. This is talking with schools. This is talking with libraries, various organizations, and letting them know not just that the eclipse is happening, but what to do. Part of the videos that I'm doing, the safety video, and then there's also, if I have time, the information video about totality in Texas. That's what I want to focus on. I'm not doing anything else, just in Texas, where basically different places in Texas, what totality is like, how long it'll last, so people have some idea. Because you can look at a map, but it doesn't really tell you anything until you really push that. Again, with the eclipse safety video, this is going out to these organizations and saying, if we do business cards or we just hand them a piece of paper with a link on it and just say, go to the YouTube channel. Here is the totality safety video. Watch this, show it to people, tell people about it, get the word out there, have them look at it. I should be done hopefully by the end of this week. I'm thinking Saturday or Sunday I'll be finished with it. I'll just go ahead and publish it, and we'll see where it goes. Also for the YouTube channel, the Hydrogen Alpha 3-hour video, I think it's like almost at 19,000 hits, which is kind of cool. The algorithm just hit it. So I've been testing. I've been trying to do some other videos. I had some issues. I fixed the tuning last night, so yay. I had
Don't celebrate yet.
I was messing with it yesterday, and I finally got the tuning just right. So it looks better. It's going to look a lot better than what it did during the annular eclipse. So lessons learned. And then afterwards, after the eclipse, for the May meeting, well, no, for the April meeting, I guess. For the April meeting, send us your videos, send us your images, and we'll do something with them. I'll put them together in like a FWAS video. Also, back to the live stream. When I asked for help, this is exactly what I mean. I'm going to have a bunch of cameras. I'm going to have a bunch of telescopes. I will automate as much as I can because I've got to be a talking head. If anyone else wants to go up there and talk, if you're going to be in Grandview, if you want to talk, we can do like interviews. We can say, talk about your experiences with previous eclipses. We need something to fill the time because otherwise I'm going to be talking for like 4 hours or however long it's going to be. And I do get tired of talking to myself, apropos of nothing, and listening to myself just talking. Primarily what I need is somebody to man cameras, but only briefly. All you will have to do, seriously, all you have to do, push the touch screen, make sure it's focused, or there's a little follow focus knob. Just turn that knob, make sure the image is focused, and that's it. That's all you have to do, and that can be done like beginning of totality, and the rest of the time you can look up. And then cover up the scopes. So not every scope is going to have, and not every camera is going to have a filter. Some are just going to be covered up. So the focusing, I'll have it dialed in pretty close ahead of time. I just need that little bitty fine focus at the end, and that's all. So 10 seconds of your time. If someone can help, like one per camera, that'd be fantastic because I'm going to be actually running the live stream and doing everything else.
I heard a rumor Robert Cargill might be spending the night at your place, so he might be able to help with that. Maybe.
No, during the event. Okay, I can focus at night. I can get all that stuff done. It's during the actual event that I would just need somebody at a camera, just fiddle that knob or just press the screen so it autofocuses, and that's it.
But I'd like to add an anecdotal deal about that YouTube video for the October eclipse. So I was just down the road from Chris. I was his emergency backup down the road in Vanderpool area. And true story, kid you not, right after I always want to say totality, right after the annularity, the peak window, folks were kind of dispersing, heading home and whatnot, heading back on the road. And a couple of guys came up, and there's cell phones everywhere. These guys looking on their phones, and he says, "Hey, there's like this guy live streaming it, like from somewhere." I'm like, "That's my boy Chris. That's Chris." So go check the chat box. I told them to sneak a little message there.
I will check that. My wife was actually checking that, and she was
the word's getting out.
moderating
The word's
it
getting out.
and
It's pretty cool.
pushing out. So yeah, anytime that you talk with people, let them know about the YouTube channel. Let them know that, hey, we do stuff like this. One of the things that we're trying to do with Rising Star is set it up so we can do remote access. I'll be able to connect and basically just do a star party, like if it's a Friday night or something, and it's clear, I can just connect, do a quick star party, 2 hours, 3 hours of imaging, show what it's like, and then shut down, and I don't have to spend 2 hours driving out there and 2 hours back and setting up all the equipment. So there's lots of plans in the works, and we just need some help. If anyone wants to learn how to do live streaming, let me know. I will set you up. I have everything that's needed, okay?
Invite them out for one of the virtual star parties.
For the virtual star parties, yeah. If you want to do that kind of a live stream, I have all the software. I can set it up for you, show you how to use it. I have, what do you call them, templates, everything is there, everything's ready to go. So all you gotta do is talk to me, and I can help set it up. Okay. Yes. Okay. Next.
But we'll press on here. So transitioning on to the outreach efforts, springboarding from the recurring ones that Mr. Patrick, he's a machine. He coordinates and attends every single one of our outreach. So we've developed a big network, right, with our schools, state parks, libraries, scout groups. And we quickly realized when we were first canvassing and interviewing, or should I say surveying all of the schools, we quickly realized there's a whole different demographic. When we do our outreach, we're looking at the public. We realize we're fighting administrations. So you've all heard on the e-groups and on the online media, the full extreme. We've seen the full spectrum. The schools that are, the ISDs that are terrified of litigation and kids going blind, to those that are fully invested and invested their own resources. Those on that other extreme, almost all of them, they're selling eclipse glasses for fundraisers and whatnot. We're no exception. Be a word on that in a sec. So we've kind of evolved our portfolio, and Patrick and Chris, they've gotten tired of hearing me talking about let's get eclipse glasses for giving out at our events and using our, kind of call it our Rolodex of frequent customers. We kind of decided let's expand, so we've kind of evolved our offerings to meet them halfway and give them no excuse to be afraid and inform them. So beyond presentations and informational and instructional to teach the educators, we also put together some kits, if you will, to hand out goodies free of charge to them. If for those watching from home or watching the replay couldn't make it out, catch us at the next events, the Tandy Hills monthly Star Party. Of course, Dano Valley, that's on a Friday next, what is the date? March something, Patrick? The Dinosaur Valley. March 8th, so 1 month from the big day. And of course, next month's meeting. Next slide, please, if you will, Bill. Yeah, it's real quick. So just some eye candy here. So every time, glasses will be sold out. As promised, we've got some been reserving a few hundred for the club. We'll have more next month, and catch us at the next outreach events. Top right, one of these is not like the others. Which guy's gonna go blind there? Don't be that guy. Be prepared. So next slide, you might have to like double click, I think. This is all your fault, Stan. Yeah, you put some animation in there. Next slide, please. DIY filters, we got the Thousand Oaks film. It's the premium high-end stuff. You see John McCrea there pimping the binoculars. You can make, one for your telephoto lens or front-end telescope. So we got the discount there. We got stock. Supplies have been diminishing. Prices have been going up. Next slide, please, Bill.
Oh, FYI, do not use a green laser to test the filters. It will punch a hole through it.
So we've had a couple of small workshops and it's been really cool to see the variety that the club member have made. Some have got a big large sheet. Some have, I think Bill's got the sexy one with like a butterfly variable brightness. I think you had that on one of your white light covers. Of course, the binocular versions. Yeah. Let's see. Fast forward. Next slide, please, Bill. So one of our portfolios of sun funnels. It's been great. It's been really worked gangbusters. Where this is how we sell that it's safe to view the eclipse instead of the fear of getting up to an eyepiece. You've all seen and heard the variations of the sun funnel. So we got our hands on 20 of them, and we're building 20 of these, and we still have some capacity. If anyone here knows of a group, a school, a library, that'd be interested, if you guys want to host, it's not necessary that we are present. We will donate these to the venues, and they can run it themselves. And it's safe. There's no fear of going blind, any of that stuff.
They're really super simple to use. You literally hit one button, and that's it. That's all you got to do.
Yeah. Next slide. I think that was almost it. This animation stuff. Yeah, we're putting the fun in funnel. Next, I think we're done. Oh yeah, and then posters. We're giving out some of those kits that we're giving out to the schools to advertise and get the word out. It's amazing. No amount of preparation and information. Folks will wait to the last minute. Family and friends reaching out the day before. Hey, you know where it's a good place to get glasses and stuff? I said, yeah, me, but I'm out of town now. So I think that was it, Bill. Oh yeah, no, I'm sorry. I want to recognize this is not So we keep growing. We still have capacity for more. Just want to hit all the current partners that we've been able to engage with. If you put these on a map, they're all over the place. So we've cast a broad net. And finally, last slide, I did want to recognize this is not the Chris and Juan show. Just recognize everyone that's participated in one form or another, helping us distribute and reach out, listening to the crazy ideas and evolving the toys and the gadgets to really get us where we are. So that's it for now. Thank you for letting us run a little long. We might have an afterthought. We might have an afterthought if we got time afterwards. I think. Cool. Thanks.
All right, thank you guys.
Turn this over. Hey, it's on mute.
Back to your helm. Oh, that's me. I'm going to turn off the light. All right. This is what's going on in the sky until the next meeting. All right. So next slide. So I'm going to start doing this, my little cover feature here. I'm going to have a slide that opens it up and takes all the words off so you can see the amazingness of, is that a word? The amazingness of the picture that's behind it. This is Jim Pott's effort of the Bernard Loop. And I think he actually got some recognition, or looked like he might, on AstroBin. But that's the, where are you? That's the Horsehead Nebula right there. Teeny tiny. So Barnard's Loop's a pretty big thing. This is a wide shot. Next slide. All right, bright comets, 10 magnitude or brighter, coming up in the next month. 12P, Pons Brooks. So, as it just happens to be, Pons Brooks was around a few years after Fort Worth Astronomical Society was founded. It's about a 70-year orbit around the sun, and it's going to be back. It's going to be magnitude 8.1. It's in Cygnus. The fun fact that actually ties to the eclipse is that according to Sky Safari, the comet is going to be at magnitude 4.7 at that point, and it's going to be 24 degrees from the sun. So there's a possibility that we might be able to see a comet in the sky during the eclipse. What up? So 144P, Kushida, magnitude 10 in Taurus. The little green thing means that it's brightening. Going back to Pons Brooks, that is going to be the comet of the year. Unless something else comes up, that one's going to be great. So C2021, S3, the Pan-STARRS, it's in Ophiuchus, and it's brightening from magnitude 9.2. And then 62P is dimming now. It's had its time, and it's going away. But it's in Virgo. I get all of my data. I get all of my information about comets on arith.net. This is a great Japanese guy that has this website, and it's just it's updated, it's kept up to date, and it's good stuff. I consider it pretty accurate data. Oh, that's Stephen Kennedy's shot of, what is that, 2022 E3 from last year. Next slide. All right, so as far as occultations are concerned, or close approaches rather, we only have one close approach going on, and it happens to be Venus and Mars. It's separated by only 37 minutes, so half of a degree. That's happening on Thursday of February 22nd in the middle of the night. Does anybody recognize what this album sleeve is? Anybody? Anybody? I'll give you a hint. Venus and Mars? Paul McCartney? Okay. All right, next slide. All right, so this is something that actually had a cover story in it from in this month's or the March issue of Sky and Telescope. T. Coronea Borealis. It is a little, magnitude 10.8 star. It's gonna go nova sometime soon. The light curve, the sort of eruption activity that's happening, the activity that's happening on this star is very similarly traced to the records of the past two eruptions, and it's really it's just a ticking clock at this point. So this one is actually on a about a 78 or 80-year cycle. So this could happen at any time. So it's just right outside of the crown there. So that's a cool one to watch. Next slide. Full moon is happening on Saturday, February 24th. This is Justin Godfrey's nice picture of the moon here. Next slide. All right, so asteroid 3, that's Juno. It's the third asteroid that was discovered. It's going to be in opposition on Sunday, March 3rd. It's my birthday, by the way. It's the 10th largest asteroid, approximately. It's shining at opposition. It'll be at about 8.7 magnitude. It was discovered by Carl Ludwig Harding, not to be confused with Carl Ludwig Hinke, who was the discoverer of 5 and 6. And I thought it was a typo at first, and I was like, okay, it's just, it's a popular name, I guess, back then. Next slide. All right, so on Saturday, March 9th, we're having our open house at Rising Star. And this is all sorts of delightful pictures from last year. This is an aerial photograph that was taken by one of those drone things. And it's this was early on, actually. The field actually got pretty loaded up. It was a really great time. And got our little coffee and cocoa bar down here. I call that the Great Attractor. It was a really, really great time. And if you're able to make it out there, we'll be announcing, all the details of that. But it's kind of an all-day thing. Next slide. All right. It is the most metal of celestial apparitions. It is the Devil's Horns. This one was taken from the last year's annular eclipse. And this is new moon, Sunday, March 10th, which is just the day after that. So we're going to have great dark skies for the open house. And just 2 moons left until that thing that we're all talking about. Next slide. So I'm going to feature Cancer the Crab. And this name it literally means crab in Latin. Ptolemy was the first to catalog it in his Almagest that he did in the 2nd century star map. It's got 2 stars with known planets. It's got 11 named stars, none of which are really very common or known or anything, so I'm not even going to bother. Next slide. 55 Cancri. So it's a binary with a yellow main sequence dwarf and a red dwarf. So what's cool about this, and you never think about binary stars actually having planetary systems, but this one, the yellow main sequence one, has 5 planets orbiting it and a star. So it's a wild little thing, and it's actually one of only 4 planetary systems with 5 known planets around them, one of which is, of course, our own solar system. So next slide. Then there's Delta Cancri, okay? The regular name is Acellus australis, okay, which actually translates in Latin to the southern donkey colt, obviously. So I'm not even gonna try to pronounce this. I tried. I was like, no, I'm not gonna do it. If I can't pronounce that comet's name that starts with a T, I'm not even gonna try this one. But it's just kind of a fun fact. There's nothing really remarkable about this star. Next slide. Messier 44. Okay, so this is one of 2 Messier objects in the crab. It's also known as Precipice. If I'm pronouncing that right, I don't know. It's called the Beehive Cluster, and it's an open cluster. It's one of the closest open clusters to us. Pleiades is another one. It contains about 1,000 stars, and most of them are red dwarfs. Go to the next slide here. M44 is right in the middle there. So that's it, and this is actually Robert Circus's image of M44. Next slide. Messier 67 is the second one. It's another open cluster. It's one of the oldest known open clusters, between 3.2 and 5 billion years. There's a number of red giants in this population, and it's down here. Notice that this is one of those constellations that actually looks like the animal for which it represents. So this is Robert Circus again. He kind of went on a little tear with clusters a while back, and so this is his capture of Messier 67. Next slide. So new general catalog 2775. It's also called Caldwell 48, Caldwell catalog. It's an amazing spiral. It's down here at the bottom here. It actually has relatively, go ahead and go to the next slide here. It actually has relatively little gas in the middle. All of the star formation is going on the outside. So it's just this big ring. It's a beautiful, beautiful galaxy. And it's not too small, and it's not too dim. So this is actually a visible thing in the sky here, to a modest, not too big of a telescope. Next slide. ARP, the Weird Galaxy Catalog. This is ARP 12. This was originally classified as a galaxy with split arms. It's up here. Next slide here. That it's actually now considered to be a pair of interacting galaxies. That doesn't look like two galaxies to me, but they know what they're talking about, and you can kind of start to see it. But if that's two interacting galaxies, then the collision has already taken place. Next slide. Beautiful galaxy, by the way. Deeper dive into cancer, where I get my information, or most of it, some of it, skylive.com and constellation-guide.com. Actually, there's 354 deep sky objects that are listed on this website right here. Also, check out universeguide.com, and of course, I always like wikipedia.com as well. So, next slide. And keep looking up. Thank you very much. By the way, Robert Cargill, I guess inspired by the purchase of his Apollo camera and maybe the moon presentation from the other month and stuff, has gotten on a little tear with moon pictures, and they're actually quite fantastic. All right, that's it. Yeah, go Robert. Okay, so go back to the meeting slide. It really gets some good detail out of that. It's really great. You're killing it. Okay, outreach reports. Lights on or off? You want me to turn on? All right. Watch your eyes. Terrible. Oh, all right.
Okay, so here's our next few star parties coming up for the next meeting. I've already put 2 of these on the e-group. So we got OS Gray this Saturday. That's always a good popular turnout. We got one on the 29th. I don't see it listed there, but there it is. No, OS Gray is this Saturday, the 24th. But anyway, I put it on the e-group earlier. Then on the 29th, we got a school in Flower Mound. Now on Wednesday the 6th, this is actually for a library. So I got a few of these between now and April where they actually want someone to give a talk about the eclipse, so I'm going to do that. I might even do a little solar viewing. So if you guys have anything you want to contribute to that, that's fine. I don't need a big turnout for that. Then we got a star party we see the U.S. Library on the 7th of March. Next slide. And then this Thursday, the date's wrong, but so it's supposed to be Friday, March 8th. It will be our first Dinosaur Valley. It's a little unusual with the open house being on the 9th. We kind of bumped it up a day. There'll be only Friday we do down there. The rest of them will be Saturday. Then also a women's club. There'll be another talk about the eclipse, as you can see there. And then we got a couple during spring break. Again, I'll post all these on the group.
And I'd like to talk about the Wildflower Ranch Star Party. Next slide. And there's more.
Keep going.
Keep going. Oh, wait. I'm sorry.
Next slide. All right, Michelle, do you have you have anything for the about Rising Star? We want to just give it to Bruce. All right, it's all you, bud.
I think it's probably his presentation that I handed off to you this morning. Rising Star. Okay, next slide. So I just briefly wanted to give an update to everyone on the utilization of Rising Star last year. We had almost 200 people come to Rising Star and sign the logbook. We know that not everybody signs the logbook when they go, but we had 196 signatures in the logbook last year. 122 people were associated with astronomy in the evening, which I thought was pretty nice. And then 57 individuals came out to do work parties to do improvements at the dark sky site. And then once we got the lawnmower running and we were able to start keeping the field, we had 17 signatures associated with that. What this is missing, though, is the open house. I didn't capture the names or the number of people that came to the open house in 2023, but I'll make sure that happens this year. So when you see the logbook upon arrival in the green building, be sure to open up the green building, reach in and sign the logbook, and we can get you can get part of the record. All right, next slide. So with the early arrival of spring here in the middle of February, I just want to give everybody an update of what the field conditions look like. We mowed it right before winter set in. The grass hasn't grown, but it is turning green. And I know a number of people have gone out to Rising Star recently, so it's ready to go. A little bit later on in the presentation, I'll talk about the construction activities and where we're at on that. Let's go to the next slide. Oh, we're here. Let's go one more. Okay, so last weekend we had a work party. 6 individuals came out, and we worked on projects above the ground and below the ground. So with the trencher, we cut trenches so we could put in the electrical lines. So we dug the trenches, we prepared and installed the conduits, and then the electrical posts that'll be out there along the, either on the pads or next to the pads are starting to take shape. Let's go to the next slide. We needed to clear our electrical easements so the power company can come in and install the power poles and then the electrical lines. So along the north fence up towards the gate, this is where the electrical lines will be coming in, and there will be a number of poles between the pole on the far side of the road and then up to the northwest corner of the observing field. Next slide. Want to make sure everybody got an idea of where we're spending the money on this. So far we've committed essentially $10,000 to the development of the project, where we're putting in electricity pads and then ultimately the storage containers. Let's go. And then in terms of new donations and commitments, what information I had day before yesterday, we had cash donations of $500 towards the project. Home Depot did not give us $2,800, but they gave us $2,800 worth of stuff. Wow. And like Bob Circus likes to say, you gotta ask. They can only say no. So that was pretty cool. And then we had a commitment. They haven't given the money yet, but they've committed to donating $4,000 towards the project. Another anonymous club member. And then future tasks, what we're going to get after this coming weekend is finalize some of the power installation tasks that we've been working on. They're going to be building the breaker panel that we need to have. They're going to run wires and other things to the pads and the observatories. Hopefully we'll get our contractor out there to pour the concrete pads, and then this coming weekend we will be erecting the dome once that's complete. We are looking for additional volunteers. Bob Circus sent out a note earlier this week, I guess it would be Sunday or Monday. If you're interested in seeing what's going on, respond to that, because they're going to have a Zoom meeting on Thursday night to consolidate the forces, to make sure that everyone knows what they'll be doing, and so the teams will then go out there and get the job done. And I think that's it for me. Oh, yeah, one other thing. The northern part of the observing field is really a construction site now. So we want to make sure that people just are aware of that, and you can go check it out, but be careful of the trip hazards that we have. Stay away from it at night, because we don't want anybody to get injured. And then once the facility is ready, the club will let you know what can be used and when you can use it. So just want to let you know that. All right, that's it for me.
Very good. All right. Thank you. All right. Wow, this. Don't know what to do. Shut the audio system off. Palo Pinto Mountain State Park report. Got anything? Okay. Announcements. So I don't know if George Lutch had anything to say about the website. All right, moving on. So, Stephen, do you? Was that in my head? Did I hear George Lutch's voice in my head? Wow, okay.
Now you heard it.
Oh, okay, hi. Do you have anything for, huh?
Nothing really going on with the website. We're kind of waiting right now to transition over to the new one on Google.
Okay. Cool. That all? That's it? Thank you, sir. Appreciate it, man. All right, Stephen Kennedy. Is Stephen on?
Hey, can you hear me now?
Yes.
Good, good. All right. Well, I wanted to chat briefly about what the APSI group is doing. The Astrophotographer Special Interest Group initiated a group imaging project last fall. We began with NGC 7822. Some of you may have seen that image floating around on Astrobin or on the through the email. Our second group project was the Heart and Soul Nebulae, and 6 different people with 6 different telescopes in 6 different locations collected more than 100 hours of data on the Heart and Soul, and we worked together to combine all of that data and then made that data available for download by anybody in the club for post-processing. And then we recently presented to you 4 options so that the club members could participate and help us select the image to be used on the group's Astrobin webpage and in social media, et cetera. It'll be submitted to NASA for consideration as an APOD, as well as to BBC Sky at Night and some others. So we had 4 entries. The first entry that you see here, a brilliant photo by Chris Ashford. I really love the detail he got here. I think this is probably, I didn't get to talk to him about it, but I think it's an HOO image. Is that right, Chris? Maybe not. Oh, well.
It's actually the color palette is a Adam Block color palette that is supposed to give you a natural color.
All right, well, and we can definitely see the natural color there. The second entry was from Jim Potts, and I think, Jim, if you're on, maybe you can talk about this. I think this looks like an SHO image. Jim, are you there? Maybe not. In any event, this was Jim's submission. The third entry was Trevor Bray. And there's Trevor's image. Trevor's is definitely a what we call the Hubble palette. And there's a lot of great detail here, and he did a phenomenal job there. The final entry was my own. I also chose to do the Hubble palette. I used sort of a different shade for the images, but we had a vote. All the votes have been counted. There were approximately 25 people who voted, and the winning entry was option 3, Trevor Bray. Trevor Bray's image, really, I think it hands down, it really is the best one. I think we had 60% of the people who voted for this image, so it was a landslide. This is the image that we're going to be using for submission to NASA, to BBC Sky at Night. It'll be on the Astrobin account. So congratulations, Trevor. I hope we'll have we'll be able to do this on a monthly basis. Next month, in theory, hopefully, we'll have the Pirates Hat image. So you won't want to miss that one. We hope you'll participate in helping us select the image for that one. And with that, I'll say thank you very much.
Well done. All righty. Does anybody have, I know you're coming up in a bit. Does anybody have any other announcements?
Hi, Bob Circus is here.
Oh, hi, Bob.
Yep. I just a couple things really quick, and I promise to be quiet the rest of the night. I want to second what Bruce said about the work weekend. We had an outstanding group of folks and who did a lot of work. And let me tell you, Saturday was just absolutely brutal. It was cold and windy, and Sunday was awesome weather-wise and just looks really awesome. I will make one comment. Bubba's Barbecue is not Bubba's Barbecue. I would advise avoiding Bubba's Barbecue on Cross Plains. And the the Messier Marathon, if everything goes to plan, may turn into our grand opening. So there'll be more details, as Bill mentioned, later on about that. Some information coming out later tonight, and that's really all I had at the moment. Oh, I did want to mention that we are going to be working with Birdville ISD for their total eclipse program. Some of you may have seen some stuff popping around on the e-groups, and what drove that is that they sent out a letter to all of their families. There's 22,500 students in Birdville. And somehow that letter wound up on cloudy nights and things really got nasty because people didn't understand how big some of our school systems are. So I sent an email to Dr. Stinson, who's the superintendent at Birdville, Thursday night, and they called Friday afternoon, and we had a meeting on Tuesday, and they've asked us to have access to the solar eclipse broadcast that Chris is managing for us and help them create some grade range specific class material. And they've asked us to provide a solar program very similar to what we did for HEB last summer. So, and they're sending information out about us to their 22,500 students' families. So I think it's a fair trade. So
That's a win.
oh yeah,
That's bringing astronomy to the people right there.
yes sir.
Very cool.
And that's what we're about. So, and that's all I had.
Okay. Oh, Michael, you're up.
Hey guys, and gals, I just wanted to piggyback off of what Bob just got talking about with the boat parties and with food during cross planes. First of all, I'd like to share my screen real quick. I don't know. There are 3 restaurants really in Cross Plains. 2 of them serve breakfast. Can y'all see the screen there?
Yes.
Okay, so Green Speed Bar and Mexico City Cafe both serve breakfast. And I've eaten at Gene's for breakfast. It's really, really good. Mexico City Cafe, I've eaten there for lunch, and their breakfast menu look really good as well. Well, I haven't eaten there. As far as where we're located, if you're looking at the map of Cross Plains, we come in off of 206. It's just, see, Gene's is about 3 blocks west on the south side of the road, and Mexico City's on the north side of the road, basically right there in the corner. And I bring this to the attention of the group because I think really for 2 reasons. First of all, for those of us who go on a work party calls and are willing to meet in Cross Plains, it will give us a little extra time to spend working. So that because when we meet at like Smokestack or New York Hill, we have to get there at 7, let's say 7:30, and then we've got an hour drive ahead of us. Well, we'll go that hour drive, and we can arrive in Cross Plains a little bit earlier and eat, and get started a little earlier. Like Bob said, this weekend is looking like it's going to be excellent weather. Personally, kind of looking at what I'd like to get done in preparation for power, there's a lot. And so I'd like to get out there a little earlier than, say, other people. I know that the dome is going to be there in the afternoon, but if there's anybody that wants to come out, I need 1 or 2 guys to come out pretty early in the morning because in order to prepare for power coming in, we have to build a raft for it. And it's going to look something like this. It's going to be a lot nicer than this. What I intend on building will last 20 years or more. But this is the general idea of it. On a sidebar, I got the opinion that maybe concrete hasn't been poured yet. Is it going to be poured by the weekend?
It's, this is a conversation for the Thursday meeting. The concrete's not been poured. It's supposed to be poured before, in time for us to be able to work on Saturday, so.
Okay. Well, assuming that we meet that deadline and the concrete is poured, we're gonna have to mount our breaker panel to something similar to this and land all of our pipes in it. And then I want to put all of our wires to the breaker panel, so that we can get all of our outlets in. And, so if anybody is interested in helping me, you don't have to have any electrical experience. There'll be no electricity at all. So it's pretty easy, but it just takes more than two hands to hold and balance and level and all of that and pull. So I appreciate your time.
Thank you so much, Michael. Does anybody have any other announcements? All right. So let's get on to the financial report.
Mike, oh, there we go.
There you go. Make it bigger. So as of today, this is the financial situation where we have $27,000 and change in our general fund. Our project fund has $7,900 left. As of today, we can't cover from the general fund everything that we've committed to for the concrete piers. So apparently there will be incoming money coming through 1687 and other avenues to cover that. You can see down there, CECA is the electric company. That's what it costs to do the installation, put the poles in and run to the home line. Below that, ACI Enterprises, that's a 10% down payment, so the entire cost is just short of $10,000. The general fund has taken $5,000 and moved it across into the project fund, as was talked about last week or last month. As far as numbers are concerned, we're officially to 200 as of now.
Woo-hoo.
Yeah.
And I just, sorry to interrupt, but we have two people have requested applications just this evening, plus one more coming from Abilene and one more coming from Copper's Cove.
And we received those where?
On Night Sky Network.
We've only received three. We received three. We had one person that made three.
Three requests, yeah, so there's two there, and
right.
We should be seeing two others pretty soon.
Right. Okay.
Excellent.
So anyway, as of right now, we are at 200. We have one that's from this meeting that hasn't finished his payment process. And the rest of the information, if we look at go ahead and scroll forward, please. Scroll forward to the chart. Yeah. So after today's meeting, we will have crossed the 200-person line. So that's great news.
I have a question. So these are 200 memberships. We don't know what the total number of people is, right? Because we could have student, individual, and family. Is there possibly a way to calculate what that might be?
Yes, there's a possibility of doing that.
You're the man. I'll pay your bribe.
When do you need it?
Next meeting would be great.
Okay.
I'm not asking for anything right now. I'm just curious.
We don't have, there's no buckets specifically set up for that, but I think I can go through there and look at the only ones that have any consequence are families. The other ones are
Yes.
just ones.
Yep.
So,
Awesome. Thank you.
yes. If you scroll back just a little bit more, right there, whoa! So there's 101 families, so that's the ones that have to be looked at. Now forward. Keep going. Whoa, right there. So I'm not going to go through all this stuff, but just to give you a general idea of what goes on in here, we did get all of the Astronomical League RASC calendars and handbooks distributed, sent out, and unfortunately the last 4 had to be sent USPS. 3 of the 4 people reimbursed me for my payments on that. We do have some anomalies. When I was doing the Google map showing where all the people lived, there are some addresses that are failing. Google says they're not valid addresses according to USPS. So I need to pull those out and send emails to those people to see if we can get that fixed. The internal examination is a feature that by the bylaws we have to perform once a year, and it usually happens in either February or March. And you can think of that as somewhat synonymous to an audit, but with not quite as many limitations. And then, just so you know, we do a sizable amount of communications with people from both through our website, info@fortworthastro.com, as well as from the Facebook channel that we have there. We get, I don't know, a dozen or more people coming through asking questions. And in fact, one of the persons I'm going to tomorrow lives down in Burleson. She has a 14-inch knob, and we're going to play collimation game. So we see all kinds of people. Is there any questions?
Thank you. All right, well, let's skip to the legal thing. Cy, you're up, kid. Chris, he's got a thing.
All right. As you know, we're trying to lease out some pads, but the bylaws don't allow us to do that. Specifically, you can see that anybody can use anything we have. So we're doing a proposed change to the bylaws, making the change in red, use of all FWAS non-leased equipment. That's changed there. And then we added something the second, further down. So do the next slide. And this talks about the lease assets. You know, the club may, from time to time, designate certain assets for lease. The terms will be whatever the executive board determines. Right now, the pads are either 1 or 3 years, but we may have something else we lease out for a shorter time. Start date will be from the day the club receives the money. The club says, okay, we got the money. Your lease starts this day and ends whatever the end time is, 1 or 3 years later. And the assets are for the sole use of lessee. So if I'm out there, I got a pad, I could sublease it to somebody else if you want to borrow it, but if you want to use my pad, just ask. I'm probably not going to go out there. But if I do go out there and you're out there, I'll kick you off my pad. So, timeline. Next slide. So, by the bylaws, we have to have this published, or at least bring it up to the club at least 30 days before we vote. We're going to publish it. George, I'll get this to you for the prime focus, and then we'll just rediscuss it on the 10th. Earliest we can vote is April 16th. Any questions on that? All right, next slide. Hey, we got June elections coming up. We got several people who, well, Robert has to move on. Monica's asked to move on because she's missed a lot of, she's traveling a lot. John has to leave. He's been there for 5 years as a treasurer, and we got two director terms expiring. We need a nominating committee because we have to bring the names up at the April meeting. So if I can get a couple volunteers to help me on a volunteer committee, nominating committee, that'd be great. Anybody? Bueller? Come on, somebody's got to help. I'm getting in her face.
I'm happy to be on the nominating committee.
All right, we got anybody else to help out? And if you're interested in being on the board, please contact me or Robert. We got 5 positions we got to fill. I'm assuming, Bill, you're going to stay on as vice president at this point in time? I thought so. I just didn't talk to you on that. So, anybody else want to be on the nominating committee? All right, then we'll just appoint people to be on the directors. Next slide. No slides, right? Young astronomers. We have our next young astronomers class next Tuesday night. Robert, what time do we start on that?
I forgot.
Yeah, I think it was
early,
5.
6. I think
Yeah,
6.
6 o'clock. And at Bedford YMCA, we could
Yeah,
use a couple
Bedford
volunteers, bring
YMCA.
some scopes out. Our class is going to be on, hey, this is a telescope and how to use it. So we're going to do a little hands-on that, and then we'll go out and actually show them how to use some telescopes. So, Bill?
And I'll double check the time. I actually met with them again this week, so.
Oh, okay. I'm sorry? Next Tuesday? I don't know what today is. I'm not looking at my watch.
Tuesday's the 27th, I think.
27th, yes.
Did we talk about 1687?
No, I just mentioned it,
Okay.
that we got our first appearance. I didn't have any details.
Okay, real briefly, I sent a note out. We need a couple of volunteers. It's Friday, March the 8th, and it'll start at 7. They're having a dinner. I need to get them a count because they're going to provide us dinner. So if you're interested, please let me know. And it's exciting. A lot of good stuff going on.
I'm going to need a hotel room and stay out there because we're back out there the next day.
Is that it? Okay. Do we have any other business? Say no. Okay. Well, next slide. I move to. Oh, right. Thank you. Sorry about that. Anybody who is a visitor or a guest here can get a free eclipse glasses in the back as just a thank you for coming out as a visitor. And thanks a lot. I move to end the meeting. We get a second?
Second.
All right. Clear skies, everybody. Watch your eyes.